Right, the trigonometric ratio, then solve for x rounded to the nearest whole degree. So, looking at where the angle's at, identify your sides. This would be the opposite side. This is adjacent. This is hypotenuse. So we have numbers on adjacent and hypotenuse, which means we're doing cosine. So our trigonometric ratio is cosine x degrees equals adjacent over hypotenuse. Then to solve this, since we're trying to solve for the degree, we have to do inverse cosine and switch the fraction with the x. And that's what we type into our calculator to get the answer. Inverse cosine, 6 over 9. Inverse cosine, 6 over 9. We need some parentheses around that. Yep, 48.2 degrees. So it's to the nearest whole degree, so 48 degrees. Do the same thing here, except this time we know the degree is 62. Identify the sides. We have opposite and hypotenuse. So sine 62 equals the opposite, 12, over the hypotenuse, x. So there's our ratio, but to solve it, we need to multiply by x, and then we'll divide by sine. So x equals 12 over sine 62. 12 divided by sine 62. 13.6, I think it says round to the nearest tenth. Nope, 100. 13.59. Here's another one, opposite. This would be adjacent. Toa. So we write tangent 27 degrees equals opposite over adjacent. To get the x by itself, we have to multiply by the 7. So that's 7 times tangent 27. 7 times tan 27. We get 3.57 if we round it. And another one, opposite, adjacent, hypotenuse. So we have numbers on adjacent and hypotenuse, so that's what we do. Adjacent, hypotenuse, cosine. Then to solve this, since x is our angle, we do inverse cosine. 3 over 9 equals x. Inverse cosine, 3 over 9. 70.53, I think it says we're just round it to the nearest whole. So 71. Identify your sides opposite. This is the hypotenuse, this is adjacent. So we're looking at TOA, we're going to do tangent. X equals opposite over adjacent. And again, since we're trying to solve for the angle, we do inverse. So we're inverse tangent. 14 over 20 equals X. We get 35 degrees. So we're going to write the ratios for sine of x and cosine y. So sine of x, we're looking at this side. Sine is opposite over hypotenuse. Here would be our opposite, 6. And the hypotenuse is 10. We could reduce that to 3 over 5. That would be okay too. And then for y, that would be adjacent, which is 6, because we're doing cosine, over the hypotenuse, which is 10. Again, you could reduce that to 3 over 5 if you wanted. Either is okay. So the idea here is that we've got sine of x, 6 over 10, cosine of y. The other angle is 6 over 10. Here, x and y, or sine of x equals cosine y. We got the same thing. So that means that x and y are complementary, which you also know just by looking at the triangle. Because complementary angles, the sine and the cosine of the two different angles will be equal if the angles are complementary. Here we're going to start with a ratio, and then we're going to solve for the other two ratios. So sine B, so here's our angle that we're worried about, angle B. Sine is opposite over hypotenuse. So the opposite side is 5, and the hypotenuse is 8. In order to figure out cosine or tangent, you need to know the third side. So we're going to solve for that third side by doing Pythagorean theorem. Hypotenuse squared, 8 squared, equals x squared plus 5 squared. Subtract the 25, you get 39. And then when you square root that, it's just square root 39. So we're looking from angle B for all of these. So this is opposite, this is hypotenuse, this is adjacent. Cosine is adjacent over hypotenuse. So adjacent, square root of 39, over hypotenuse, 8. Tangent is opposite over adjacent. So 5 over square root of 39. And another way that you could write this 5 over the square root of 39 is to not have the square root in the denominator. We're going to rationalize the denominator. You do that by multiplying by that square root to both numerator and denominator, top and bottom. So when you do that, you get 5 times square root of 39 is 5 square root of 39. And then square root times itself, you just lose the square root symbol. It just becomes a whole number, 39. So there's actually 2 ways you could write tangent here. We have 5 over the square root of 39 or 5 square root 39 over 39. Similar question, sine C, so here's our angle, opposite hypotenuse. The opposite side's 8, the hypotenuse is 17. We have to find the third side. Hopefully you recognize this as a Pythagorean triple. If not, you just solve it out. 17 squared equals 8 squared plus x squared. 17 squared is 289, 64. So you subtract the 64 and you get 225 equals x squared. So x equals 15, which you could have saved all that time if you recognized it was an 8, 15, 17 Pythagorean triple. So to find cosine of C, that's adjacent over hypotenuse, 15 over 17. And then tangent is opposite over adjacent, 8 over 15. Complete the ratios for sine of P, or for sine and cosine of P and angle Q. So for sine of P, looking at this angle, which means we have opposite, adjacent, and hypotenuse. So sine, which is opposite over hypotenuse, would be 12 over 20. Or you could reduce that, divide by 4, you get 3 over 5. For cosine, it's adjacent over hypotenuse, which is 16 over 20. Or you could reduce that, divide by 4, you get 4 over 5. For angle Q, you just change your reference. So now this is opposite and this is adjacent. So sine is opposite over hypotenuse, 16 over 20, which again reduces to 4 over 5. And cosine would be adjacent over hypotenuse, which would be 12 over 20, which reduces to 3 over 5. And like we mentioned a few problems ago, I think it was number 6, since these are complementary angles, P and Q are, that means sine of P is going to equal cosine of Q, and cosine of P will equal sine of Q, because they are complementary. So we'll get to some word problems now. 20-foot ladder leans against a wall. In order for the ladder to make a 55-degree angle with the ground, approximately how far should the base of the ladder be from the wall? So we want a 55-degree angle with the ground. The ladder is 20 feet. And it's asking how far from the base should the ladder be from the wall. So this distance down here. So we have adjacent and hypotenuse. We're doing cosine. 55 degrees equals adjacent over hypotenuse x over 20. So we're going to cross multiply, solve this out. So 20 times cosine will give us x. So 20 cosine 55. 11.47. Doesn't tell us how much to round, so let's just keep it that way. 11.47. That would be in feet. So to approach a runway, a small plane must descend at an angle of 12 degrees, angle of depression. So from looking out, depression's looking down. That's 12 degrees. The angle of depression is always the same as the angle of elevation from the ending point that they're looking at. If the plane is at a height of 2,250 feet, to the nearest tenth of I should say feet. How many feet from the runway is the airplane at the start of the approach? So how many feet from the runway? That's what we're looking for right there. So we have our triangle. Here's our angle. This is opposite. This is adjacent. That's tangent. Opposite over adjacent. Cross multiply, solve this out. So you're going to multiply by the x and then divide by tangent. So 2,250 divided by tangent 12. 10,585.4 feet. That's just over 2 miles if you converted it. But you don't need to. A tower with a height of 150 feet. So here's our tower, 150 feet. Casts a 203-foot shadow. Find the angle of elevation of the sun to the nearest whole degree. So if you're standing here looking up, that's the angle of elevation that we're looking for. You'd be looking up here to the sun. So to find that angle, we have an opposite side, we have an adjacent side, that's tangent. Opposite over adjacent. Since we're solving for the angle, we do inverse tangent, 150 over 203. Inverse tangent, 150 over 203. We get 36.46 to the nearest whole degree, so just 36. An adult slow-pitch softball diamond is a square with sides of 65 feet. What is the shortest distance to the nearest tenth of a foot between first base and third base? So we'll put first and third are across from each other. We'll go this way. We're trying to solve for that length right there. So we don't need the whole square. We actually just need that triangle that we just formed. The two sides are 65. We're trying to find the hypotenuse. So there's a few ways you could do this. You could recognize that since these sides are the same, that means the angles are the same, which means it's a 45, 45, 90 triangle. And the relationship for that is that the two sides will be the same, and the hypotenuse is just times the square root of 2. So if you did that way, you would just jump right to the answer, 65 square root of 2 feet. Nearest tenth of a foot, you just have to type that into your calculator. 65 square root of 2. 91.9 feet. If you didn't recognize it was a 45, 45, 90, you would just do Pythagorean theorem and do 65 squared plus 65 squared equals x squared. So you'd have 65 squared plus that same number again, so times 2. And then we square root that answer to get x, and you're going to get the 91.9. Square root of 8450 is 91.9, so same answer. Find the lengths of the given sides, provide your answer in exact form, and approximate to the nearest hundredth. So exact form means we're going to have square roots in our answer. The approximate means you're going to type that square root into your calculator and get the decimal. So again, we're looking at this triangle. We've got two angles that are the same, so it's another 45, 45, 90. Which means these two sides are the same. The only difference is that square root of 2. Side to hypotenuse is equal to the side has a length of 1 and the hypotenuse has a length of square root of 2. Then you put the side, which is what we're trying to find, over the hypotenuse, which is 20. And you just solve this proportion. You get 20 equals x times the square root of 2. Divide by square root of 2. And whenever you are dividing by a square root, you could do the rationalize long process, which would be 20 square root of 2 divided by 2. Or you can just remember the shortcut, which is you divide the numerator by 2, get 10. And just remember that there needs to be a square root of a 2 on it. It's the same thing, just a little bit of a shortcut. And both legs will be the same, both sides will be the same, so this is also 10 square root of 2. Then to approximate, just type that into your calculator, 10 square root 2. 14.14. The other way you could set that up, you could just go back to what you remember about sines and cosines of 45-degree angle. If you're trying to find this side, it would be opposite over hypotenuse. That would be sine. And you know this is 45 degrees equals opposite, which is x over 20. And then you remember that sine 45, if you did the left-hand trick, that would be square root of 2 over 2. Put your middle finger down to get 45 degrees. And then you cross multiply that. You get the same answer, 10 square root of 2. For this other triangle, it's a 30, 60, 90. If you just remember the relationship, the hypotenuse is twice as long as the short side. So if the hypotenuse is 6, the short side's 3. So AB is 3. There's no need to round that because it's just 3. AC, the long side, is times the square root of 3 because a 30, 60, 90 is 1, 2, square root of 3. So this would be 3 square root of 3. You can get that from your calculator to get the approximate. 5.196 would round to 5.2. Now, if you didn't remember the 30, 60, 90 shortcut, you would have to do it using sines and cosines. So to get this side, you would have sine of 30 equals AB, call it x, over the hypotenuse, which is 6. Then you would replace sine of 30 with 1/2. And then cross multiply. You can see you'd still get 3. If you did the other one, you'd have to do cosine 30 for adjacent over hypotenuse. You call that y. Adjacent over hypotenuse would be 6. Then you'd replace cosine 30 with, you fold down your ring finger for the left-hand trick, square root of 3 over 2. And cross multiply that to solve and get 3 square root of 3.